Hello and welcome to our video solution to problem 16 from Superquiz 3. This was another optional problem. This time we're assessing the fundamental theorem of arithmetic, the first of two such problems. And this is actually a very straightforward problem in that it's talking about something from elementary school, which is in elementary school they say, well, take a number like 3,780, although when I was in elementary school I don't think they ever gave us a number that big. And they say, okay, so you take the number 3,780 and we want to make a factor tree. So you're going to keep on factoring the number until you get down to all primes. And so maybe the first student does it in this way. They end up with 2 2s, 3 3s, a 5, and a 7. And a second student, you can see, gives a very different factorization. For example, they start by doing 20 times 189 rather than doing 2 times 1,890. And at the bottom, you can see the order of these primes is very, very different. There's a 2 over here and a 5 over there. But if we check how many times we get 2, let's see, there's 2 2s, and here's 2 2s. And how many 3s? Well, let's see, there's 3 3s over here and 3 3s over there. And let's see, then we get 1 5 and 1 5. And we get 1 7 and, 1 7. So even though they appear in a different order and the tree itself is absolutely very different, the primes we get at the bottom are exactly the same, and they occur the same number of times. And the question is why? Of course, the answer is very straightforward. It's just the fundamental theorem of arithmetic. All right? So every factor tree results, assuming it's correctly done, results in a prime factorization of the original number, right? The top of the tree. And the fundamental theorem of arithmetic says that if you take first any number, there will be a prime factorization, but if you take any two prime factorizations, up to the order of the prime factors, they're going to be the same. That is, you're going to get the same prime numbers, and they're going to occur the same number of times. So by the fundamental theorem of arithmetic, each factorization will have the same primes, and they'll occur the same number of times. So we'll have the same primes and they will occur the same number of times. So importantly, if you ever end up teaching elementary school students or this process of factoring, is you can make up your key in the sense of you can factor the number in some way, write down one factor tree and get the prime factors and how many times they occur. And then any other student can do it any way they like, and all you have to do is check the bottom, right? And you don't have to worry that they're going to get a different correct answer than you. There's only one correct answer up to what order they write things down in. All right, so the things that we're learning in this upper division math class, all right, actually go back to justifying some of the work you did when you were very, very young. And of course, they weren't at the time probably going into all the details of the fundamental theorem of arithmetic. They certainly weren't talking about its connection to other rings, other number rings that we've dealt with. But hopefully you're starting to see that there are a lot of deeper ideas that even go along in the elementary school curriculum.